Hey guys, just thought I would post something for the upcoming test on Chapter 5. Uh, Here is a practice test or review. There's a lot of problems on this. There won't be as many problems on the test, but there will be all of these type of problems on the test. So just figured I'd post this so you can see what I do. So first of all, there will be a non-calculator portion on the test and a calculator portion on the test as well. But yeah, just keep that in mind. But in any case, okay, so for one, we have 1 and 2, we have logarithms, and it says rewrite each equation in exponential form. So an exponential form, if you remember, that exponential form is b to the x is equal to y, and you can go back and forth between exponential and logarithmic form using this definition right here. A log base b of y is equal to x. So you can see that b is always the base, no matter if it's an exponential or a logarithm, b is the base. Okay, x is the exponent for an exponential, and on the other side of the equal sign for a logarithm, that's where the x is. And inside the logarithm is the y, and that's what the exponential will equal. So here I have 361 as my base. That'll be the base of my exponential. My exponent of the exponential will be 1/2, and it will be equal to 19. And then for number 2, 16 is the base. The exponent would be -2, and it would be equal to 1 over 256. Okay, for 3 and 4, we're just going to be taking the exponential and going into a logarithm. So for this one right here, it was a logarithm to an exponential, and now we're in exponential form. We're going to convert to logarithmic form. So this one will have a log base 13 of 169, and this will be equal to 2. This will have a logarithm of base 16 of 1 over 216, and this will be equal to 3. So what I like to do for logarithm, whenever I'm going from exponential to logarithms, remember that the exponent is what the logarithm is equal to, because that's what logarithms are. Logarithms help us define what exponents are. So this exponent is equal to this logarithm right here. All right, for 5, which one of the following expression is equivalent to x? So for this one, it's looking for you to use the property of log base b of b is equal to 1. And notice that these don't specify the base of the logarithm, so that means they're common logarithms, and common logarithms have a base of 10. And you can see here that this right here is a log base 10 of 10. So those are inverses operations, so this will result in just x. And so there you go. So A has to be that right there. Okay, for 6 through 9, to expand the logarithm. So for this one right here, there's 3 properties of logarithms to expand. So if you have a logarithm base b of m multiplied by n, this is equal to a logarithm base b of m plus a logarithm base b of n. And then there's the quotient property, log base b of m divided by n. This is equal to log base b of m minus a log base b of n. And then there is the power property, which is log base b of m raised to the n is equal to n times by log base b of m. So we have the product property, quotient property, and power property of expansion. Here I can see that these 2 terms right here inside the logarithm are being multiplied. So I'm going to first expand those. So this will turn into a log, and the base is it's just a common logarithm, so I'm not going to write the base. So log of 2 cubed, and then plus log of x to the 1/3 power. Notice that I'm writing this as an exponent so that I can use my power property, drop the 1/3, and make it a multiplier of the logarithm. I'll do the same with the 3 over here, so I'll drop that 3. So 3 times by log of z plus 1/3 log of x. Okay, and there's nothing else inside the logarithm, no products, no quotients, no powers, so we've expanded it as much as we can. Alright, for 7 we have a natural logarithm. Again, we have a product, so I'm going to separate those. Make sure that you don't pull any powers down before it's too soon. So make sure to do that after you expand products, unless the power applies to the product itself. So in this case right here, this would be the natural log of c to the 5th plus the natural log of a to the 1/2. Again, just making this an exponent so that I can drop it in the next step. So I'll drop the powers, so 5 natural log of c plus 1/2 natural log of a. And once again, what's inside the logarithms, there's no more products, powers, products, quotients, or powers, so we've expanded as much as we can. For 8, so in this case right here, this would be the case where it'd be appropriate to drop the power first, since the power is outside of the because the quotient is inside these parentheses and the power is of the quotient. So we're going to drop that 6 first. So it's going to be 6 log base 9 of u divided by v to the 4th. Okay, I'm going to separate these through subtraction because it's a quotient. Now I do have a multiplier outside of here, so I need to put in parentheses my difference. So this is going to be log base 9 of u minus log base 9 of v to the 4th. Again, this 6 applies to both logarithms because I separated this logarithm, or I expanded this logarithm while it had a multiplier. And then this one's good. I just need to drop the 4 down there. So this would be 6 log base 9 of u minus 4 log base 9 of v. And then I'll distribute the 6 to both terms. So I'll have 6 times by log base 9 of u minus 24 log base 9 of v. And there you go. For number 9, again, I have this power that I'll need to drop before I expand these two right here. So I'll drop the 5. So this will be equal to 5 log base 5 of a squared divided by b. Now I'll separate these two, but remember I have a multiplier, so this will be equal to 5 parentheses log base 5 of a squared minus log base 5 of b. And then this will be equal to, I'm going to drop the 2 down right there. So 5, and then I'll have 2 log base 5 of a minus log base 5 of b. And then I'll distribute this 5 to both logarithms. So I'll have 10 log base 5 of a minus 5 log base 5 of b. Alright, so that is expansion of logarithms. Now we're going to condense logarithms. So essentially we're going to take logarithms being multiple logarithms and logarithms that have coefficients, and we're going to condense them into single logarithms. Alright, so for 10, I'll just start with these two right here. I have an x, a natural log of x, natural log of y. Okay, so with these right here, I can combine them into one natural log of natural log of x times by y. Okay, so multiplying them into one logarithm. I'm going to take that 3 and move it up to be the power of that z. So this is going to be minus the natural log of z to the third. And then one more time, I want to reduce this into a single logarithm. So this is going to be the natural log of xy divided by z to the third. And there we go. For this one right here, so again, I'm going to look at the coefficients of the logarithms, move them to be powers first. So this will be a log of x to the 8th plus log of y squared. Because they're being added, I'm going to condense them into one logarithm, log of x to the 8th times by y squared. And there you go. For 12, again, looking for anything that's a coefficient. I'm going to move it up as the exponents. So I'll have log base 3 of b squared plus log base 3 of c to the 5th. Then plus log base 3 of a to the 1/3 power. And you can see that all these are being added. So whenever I condense them into one logarithm, they're all going to be multiplied inside. So that's going to be b squared times by c to the 5th times by a to the 1/3. And if you want, you can even write this right here as the third root of a, but I don't mind if you keep it as a to the 1/3. Either's fine with me. So there you go. For 13, coefficients, I'm going to move them. So this one doesn't have one, so we're going to just have log base 3 of b minus log base 3 of c to the 4th, and then plus log base 3 of the square root of a, since a to the 1/2 power is the square root of a. Now, yes, I can use this as a quotient right here, so we can go ahead and do that. So make this a quotient. So this would be a log base 3 of b over c to the 4th. And then we have the plus log base 3 of the square root of a. And then I can multiply this by this right here. So that will be a log base 3 of b square root of a multiplied on the numerator, and then c to the 4th still in the denominator. And there you have it. Okay, evaluate each expression. So for these ones right here, these are just logarithmic expressions. You can go ahead and just make them into equations if you need to. So you're trying to find the numeric value. These represent a numeric value. So we're not going to use calculators for this portion right here. But what we can do is we can simplify this into, or we can rewrite it in exponential form. So exponential form would say that this would be 2 to the x is equal to 1/8. And I know that 2 to the power of 8 is equal to 8. And since this is 1 over 8, then that just means that the exponent will be negative. So this means that x will be equal to -3. So in this case right here, this logarithm has to be equal to -3. For 15, I'm going to use that same strategy, just make this equal to x. So 9 to the x will be equal to 3. And then I just have to think about what does this exponent have to be in order to make this 3. I know that the square root of 9 is 3. So, and I know the square root as a power is 1/2. So that means x has to be equal to 1/2. So this logarithm is equal to 1/2. 16, so I'll set this equal to x. 4 to the x is equal to 1/16. I know that 4 squared would be equal to 16, so the fact that this is 1/16 just means that my exponent is negative. So x would have to be equal to -2 instead of 2. So the numeric value of this logarithm is equal to -2. This logarithm right here, again, I'll say this is equal to x. So we'll say 64 raised to the x power is equal to 1/8. And I know that, again, the square root of 64 would be 8, but this is 1/8. So not just 1/2, this would have to be -1/2 because it's a fraction over here. So this means that x would have to be equal to -1/2. So the numeric value of this is -1/2. For 18, set that equal to x, so 6 to the x power is equal to 216. X to the 6 to the third power is 216. So that just means x would have to be equal to 3. And so this is equal to 3. Okay, let's see, we have this one, we'll set this equal to x. We'll say 5 to the x is equal to 125. 5 to the third power is equal to 125, so x has to be equal to 3. So this is equal to 3. Okay. Graphing logarithms and exponential equations. So these are logarithms. So graph each function with a vertical asymptote, state the domain and the range. Make sure you label at least 3 points on the graph. Depending on how it goes, I might just change this to 2 points rather than 3. But if you follow these steps, it shouldn't be bad. The main thing about graphing these logarithms, again, you won't have a calculator, but the main thing about graphing logarithms is that they're inverses of exponential functions. So if you remember, we said, maybe we can go over 24 through 27 first, so that I can explain just a little bit more clearly. So in any case, exponentials. So let's take this one, the first one that we have here. This is base 1/3 of x and then plus 4. So just keep a note that if the base is less than 1, this is going to be an exponential decay rather than exponential growth. So keep that in mind. But no matter what the base is, if the exponent is 0, so 1/3 to the 0 power, it's always going to be 1. So we can say that, but also this is a shift up 4. So not only is it going to be here, but we have to move it up 4 spaces. But I'll do that in just a second. Okay, I just wanted to show you how I first do my first point right here. So that's going to be 0, 1. Okay. Now I know that since this is decreasing, it's probably better if I work this way instead. Now, I know that 3 to the x power, again, the point would be here at 0, 1. The next point would be at 1, 3, since 3 to the first power is 3. So it would be right here. So, and then you can even go further. You could say 3 squared would be equal to 9, so the next point would be probably like right there. Now, because this is a base of 1/3, these points are actually going to be, well, this will be here, but it would be going the other way, so next point would be right there. So the actual function for this function without the plus 4 would be like this right here. and remember the asymptote right there. Okay, now let's account for the shift up 4. So this means that everything will be shifted up 4. So this is going to go up 1, 2, 3, 4. So right here. This point right here will also go up 4. So 1, 2, 3, 4. I think I'm missing out 1, 2, 3, 4, and 1, 2, 3, 4. Yeah, right there. Okay, and then the asymptote, which was here, will also be shifted up 4. So the asymptote, which is at the line y equals 0, will now be at the line y is equal to 4. I'm going to erase this graph that we had here. And here we go. Should just be an exponential that looks like this right here. Okay. Remember that exponentials have a domain of all real numbers, and the range depends pretty much just on the asymptote. In this case right here, we are always greater than 4, so this will be y is greater than, not equal to, 4. Remember that it cannot be equal to because of the asymptote right there. So in this case right here, we could only fit 2 points on this right here, pretty much. I mean, you could try and do more points down here, but it doesn't make sense. So 2 points would be perfect right here. Let's see if there's anything else we need to include. So graph each function. Vertical asymptotes only apply to logarithms. State the domain and range and make sure you label at least 3 points. So the vertical asymptote in this case, this would be you would need a horizontal asymptote for exponentials. So there you go. And if you needed to, you could also state that this is y is equal to 4. All right, let's try 25. Okay, so for 25, we have base of 3 rather than 1/3. So since it's a base of 3, you know it's going to be growth. The x minus 2, this means it's going to be a translation 2 units to the right, and this is going to be a translation 1 unit up. So I'm first going to get my original points. So 3 to the x would be right here, like we said before, right here, and right here. So all of these points are going to be moving right 2 and up 1. So the next point would be, so for this point we'd move it right 2 and up 1. So right 2 and up 1. This point right here is going to go right 2 and up 1. So right 2 and up 1. Okay, and then this one right here, well, of course, off the graph would be right 2 and up 1. The asymptote for exponentials would be right here, and the asymptote doesn't matter moving left to right. It's still going to stay right there. So it only matters that we move it up right there. Let me get rid of these dots right here, though. So this is going to be right here, we'll say. And then, okay, so we have a point here, and we'll follow this along the asymptote, and then it will grow up like that. Okay, so in this case, domain, it's exponential, all real numbers, range, y is going to be greater than 1. And there we go. That should be everything you need for the graph. You have the 2 points. This would be the line y is equal to 1. And there you go. Alright, for 26. So this one has a base 4. Okay. It's also negative. Since it's negative on the outside, that's going to be a reflection over the x-axis. And then plus 3. Excuse me. So let's just start with 4 to the x. 4 to the x, again, 0, 1, always. And then 1, 4, since the base is 4. So those are going to be the first points of the function, just like that. But the function is going to be reflected over the x-axis. So this point right here would be right here. And then we're going to move it up 3. 1, 2, 3. So right there. This point right here will be reflected over the x-axis, so that would come down to here, and then up 3, 1, 2, 3, so right there. The asymptote, which would be right here, is going to be moved up 3, 1, 2, 3 right there. Let me get rid of these points right here. And again, it's going to be, because of the reflection, it's going to be going downwards like this. And there you go. Domain, still going to be all real numbers. And the range will be y is less than positive 3. So this right here is the line y is equal to 3. Alright, and this last one right here, we have a base of 1/2, so this is going to be a decay function. So coming down like this rather than like this. Remember that this is neither decay or growth because it was reflected over the x-axis and moving down like that. Okay, so base 1/2, just for the sake of it, just going off of 2 to the x, so that would mean that you have our starting point here, point right here, 2 squared would be to the 4th, 2 to the 3rd would be to the 8th power. Now 1 over 2 would just be the other way, going the other way, so right here, here, and then here. So this would be the points for the function of 1/2 to the x. Okay, so let's talk about the transformations now. So the transformations we have are right 1 and up 2. So all these points right here, all these points are going to be moved to the right 1 and up 2. So this point right here will be right 1 and up 2, right 1 and up 2, right 1 and up 2, right 1 and up 2. That one will be off the graph. Get rid of those. The asymptote, which would be here, will be moved up 2 units. And there we go. We have our graph ready to go. And just like that. So in this case, we were able to fit 3 points, no problem. That's great if you can. If you can just do 2, that's fine as well. Domain, all real numbers. The range would be y is greater than 2. Since this is the line, y is equal to 2. Okay, now going back up to logarithms. So to explain logarithms, logarithms are the inverses of exponentials. So take the base. If this were an exponential with a base of 1/4 to the x, we would say it has a starting point here. It's decay, so it would have the next point right here, and the function would come down like this right here. Now, because it is a logarithm, the points will be inverse, will be flipped. So this is the point -1, 4. This is the point 0, 1. So that means that its logarithmic function will have the points at 1, 0, and at the point 4, -1. So 4, -1. So right here. So get rid of these, get rid of these. And instead of the asymptote being like this, for logarithms, the asymptote runs vertically. So the vertical asymptote would be right here. And you can see that the function would move along that asymptote rather than horizontal. It would move vertical. And it would go like this right there. Now, so that would be the parent function if it were log base 1/4 of x. But in this case right here, we just have to move it to the right 2. So because of the transformation. So all these points and the asymptote, we're going to move right 2. So this point right here will be right here. This point right here will be right there. And the asymptote will move right to there. and then just draw the same graph. Just like that. Okay. And that should be good. In this case, we could only fit 2, so, and that's fine, just as it is. Okay, for domain and range, now because their inverses, x's and y's are flipped, so in this case the range is all real numbers. You can see that on the graph, it just keeps going. And the domain is restricted to being greater than 2. Since this is the line, x is equal to 2, so domain x is greater than 2. Alright, let's try this one right here. So we have a couple of transformations. Let's first talk about just log base 5. Let's graph that one. Just remember, okay, so, and because this is the base right here is greater than 1, unlike over here, which was less than 1. So instead of coming down, or coming from the positive side, going like that right here, we'll be coming from the negative side and going up like that. Kind of just like how exponentials work, but now we're doing logarithms. So we always start with this point right here, 0, 1, or 1, 0 in this case right here. And because it's the base of 5, it will be right here. Just again, just to explain that, if it were 5 to the x, we would say it would be a point right here. That's the point 0, 1. And the next point would be 1, 5. And because this is a logarithm, its inverse, which would be switching the points, so 1, 0 and 5, 1 right there. So this right here is logarithm base 5 of x. So like that. Okay, now let's take into account the transformations. So we have a multiplier by 2, so that's a vertical stretch by 2, and that would be right 3. So now this right here, it doesn't, since the y value is 0 and it's a vertical stretch, vertical is the y dimension, if I multiply it by 2, it doesn't change. 0 times by 2 is still 0. So I just need to move that to the right 3 units. So 1, 2, 3 right there. This point right here, since it's one distance away from the x-axis, I'm going to vertically stretch it by 2. So that would mean that it would go right here. And then I'm going to move it to the right 3. So 1, 2, 3. So that would be right there. And the vertical asymptote, which was along the y-axis, will be moved 1, 2, 3, just like that. And then go ahead and graph this. It'll go like that, and there is our function. So the domain would be x is greater than 3, range is all real numbers. And this is the line x is equal to 3. For 22, we have a multiplier shrink by 1/2, log base 5 of x plus 2. This plus 2 is outside of the x, so this is going to be a vertical shift up rather than a horizontal shift left or right. So keep that in mind. And we have a log base 5 again, so using the same beginning points right there and right there, this would be a log base 5 of x. Okay, now let's take the transformation. So a shrink by 1/2. So talking about the first point right here, if I shrink this by 1/2, doesn't change because we're at the x-axis. I just need to shift it up 2. So 1, 2. Okay, and then this point right here, the distance from the x-axis is 1, so shrink it by 1/2, that would be right there, and I have to move it up 2, so 1, 2, so right there. And the asymptote did not change because we did not move left or right, so the vertical asymptote doesn't change. And then we have our graph, so it'll come up like this, and it'll go out like that. Okay. Try 23. So for 23, we have -2. So this negative would mean it's going to be reflected over the x-axis, stretched by 2, and then down 3 since this is outside of that, so down 3. And it's a log base 5. So log base 5, so again, let's take our beginning points, so just like this right here. And now let's do the transformation. So reflect over the x-axis. If I reflect this over the x-axis, doesn't change. It's going to be stretched by 2. Okay, so that means it's going to be down here. And then we're going to, so stretch it by 2. Well, sorry. Reflect it over the x-axis. That doesn't change since it's on the x-axis. Stretch it by 2. That's not going to change because it's on the x-axis, but we are going to move it down 3. So 1, 2, 3, just right there. For this point right here, reflect it over the x-axis, so that would move it to here. Stretch it by 2, so the distance here is 1. Now it's going to stretch to 2, and then we're going to move it down 3. So 1, 2, 3. So that's where this new point is going to be right there. And the asymptote didn't change since we didn't move left or right. And we'd be coming from up here because of the reflection over the x-axis. And there you go. So we'd have a range, all real numbers. Sorry, I forgot the range and domain over here. All real numbers. This would be x is greater than 0. This would also be x is greater than 0. This would be x is equal to 0. This is the asymptote x is equal to 0. So, okay, so that should cover graphing. I'm going to change that to 2 since really we can only fit 2 points right there, and that's fine with me. Okay, so there you go. All right, so on to a calculator portion. So calculator portion is allowed for these type of problems right here. So solving equations. All right, so here I have log base 19 n plus 5 equal to log base 19 of 3n plus 1. Now, because these logarithms are the same base right here, they essentially don't really mean anything in terms of solving the equation anyways. So that means I don't really need them to solve the equation, so I can just take n plus 5, what's inside the logarithm, and set them equal to each other. So n plus 5 is equal to 3n plus 1. I'll subtract n from here, subtract n from here, and then I'll subtract 1 from here, subtract 1 from there. So this is going to be 0, that's going to be 4. This right here is going to be 2n. And of course this will be 0. So I have 4 is equal to 2n. Divide by 2, divide by 2. And I get n is equal to 2. And there you go. Alright, let's try the next one right here. So I don't have a logarithm on both sides, so I can't use the same equality property here. But what I need to do is get the logarithm isolated. So first I need to deal with this right here. So I need to add 2 to both sides. So now I'll have the natural log of n plus 8 is equal to, in this case it will be equal to 0. Okay, and then here I can do one of two things. I can exponentiate both sides with a base of e, or I can rewrite it in exponential form. Either way you get the same thing. So e to the natural log, remember that the natural log has a base of e, so essentially these will cancel and leave me with n plus 8 equal to e to the 0 power. Now e to the 0 power is equal to 1, so I'll have n plus 8 is equal to 1. I'll subtract 8, subtract 8, and I'll have n is equal to -7. And there you go. Okay. Let's try this one over here. For 30, I have 2 logarithms on one side. So what I want to do is to condense this into one logarithm. And because they have a base 9, I can condense these into one logarithm using multiplication. So condense, so log base 9 of 3 multiplied by x squared minus 1 equal to 1. Okay, and then that's just going to be, we'll just say log base 9 of 3x squared minus 3 equal to 1. Okay, and now I can get rid of the logarithm. Since the logarithm is isolated, I don't have anything being added or subtracted like this one right here, or any coefficients. So in order to get rid of the logarithm, I have to exponentiate. So in this case, I have to exponentiate with a base of 9. So this base 9 and log base 9 would cancel, and I'll be left with 3x squared minus 3 equal to 9 to the first power, which would be 9. Now this is a quadratic, but I don't have a middle term, which is easier to solve. So I'm just going to solve for x. So by adding 3 to both sides, so I have 3x squared is equal to 12. Divide by 3. So I'll get x squared is equal to 4. Take the square root, take the square root. I'll get x is equal to plus or minus 2, since the square root of 4 is plus or minus 2. I just need to make sure that if I plug a -2 or a minus, if I plug these answers into this logarithm right here, that I don't make what's inside negative. So for instance, if I plug in positive 2, that becomes 4 minus 1, which would be 3. If I plug in -2, well, -2 squared is still 4, minus 1 is 3, so both work. Okay, so we're good. For 31, let me just put this right here. Okay. For 31, again, we have 2 logarithms with the same base, so I'm going to combine those. Since I'm subtracting, though, I have to divide. So this will be a log base 4, 2x to the 4th divided by 2. This will be equal to 3. And 2x to the 4th divided by 2, that's going to be, I could just write that as log base 4 of x to the 4th. And that's going to be equal to 3. Okay, so then let's see, I can exponentiate this both sides with a base of 4 to get rid of the logarithms. So this right here, this would cancel, leaving me with x to the 4th equal to 4 to the 3rd. 4 to the 3rd would be 4 times 4, which is 16. 16 times 4, which is going to be equal to 64. Okay, and then from here I'll do a 4th root on both sides, and the 4th root of 64, I believe that would be equal to, actually I'm not even sure, but we can use a calculator on this portion. So let's do 64 raised to the 1 divided by 4 in your calculator. And yep, you should get a decimal number. So in this case right here, let me just show you really quickly here. 64 raised to the 1 divided by 4. And you get 2.828. 2.828. And I guess you could also say plus or minus, since 4th roots give positive and negative. So that should be good right there. Alright. Log base 8 of x minus 6 minus log base 8 of 10. I'm going to condense these two logarithms first. So I'll have a log base 8 of x minus 6 divided by 10 equal to 1. Okay, I'm going to get rid of the logarithms by exponentiating with a base of 8. So 8 and 8. So these would cancel. I'll be left with x minus 6 divided by 10 equal to 8 to the first power, which is 8. I'll multiply both sides by 10. So multiply by 10, multiply by 10. These would cancel, and I'll be left with x minus 6 equal to 80. And then I'll add 6 and add 6. I'll get x is equal to 86. All right. 33. I have two logarithms here, base 5, so I'm going to condense that into one logarithm. So that would be a logarithm base 5 of x plus 7 divided by 3 equal to a log base 5 of 65. Again, notice that I have logarithms on both sides with the same base, so the logarithms are not necessary to solve the equation. So I'll have x plus 7 divided by 3 equal to 65. Multiply both sides by 3. So I'll get x plus 7 is equal to 65 times by 3 is 195. And then I will subtract 7, and I'll get x is equal to 188. Okay. 34, I have the inequalities now. Inequalities shouldn't really be all that different when it comes to solving anyway, so I have negative 3 log base 2 of b minus 10 is greater than or equal to negative 6. So I'm going to divide by negative 3, divide by negative 3. Since I am dividing by a negative number, that inequality does need to flip signs. So this will be a logarithm base 2 of b minus 10 will be less than or equal to 2. I'll exponentiate both sides with the base of 2. So base 2, base 2. So I'll have b minus 10 is less than or equal to 4. Plus 10, plus 10. So then I'll have b is less than or equal to 14. Okay, let's try 35. So for 35, first thing that I'm going to do is isolate the logarithm. So I'm going to add 4 and add 4. So I'll have a logarithm base 4 of negative 4x is greater than or equal to positive 2. Exponentiate both sides with a base of 4. So I have negative 4x is greater than or equal to 16. I'll divide by negative 4, divide by negative 4, and I'll get x is greater than or equal to, will be less than this time since we're dividing by negative 4. So because we divided by a negative number, flip the inequality, so less than or equal to negative 4. For 36, isolate the logarithm. So subtract 10, subtract 10. So I have a log base 9 of x minus 3 is less than or equal to 2. Exponentiate both sides with a base of 9. Just to give myself a little bit more space. So I'll have x minus 3 is less than or equal to 9 squared, which is 81. plus 3, and plus 3. I have x is less than or equal to 84. Okay, over here, first thing I'm going to do is isolate the logarithm, so I need to get rid of this right here. So I'll subtract 1, negative 2, log base 2 of b minus 3, which would be less than or equal to negative 4. One more step, I'll have to divide by negative 2, which means I'll flip the inequality as well. So I'll have a logarithm base 2 of b minus 3 is greater than or equal to 2. Exponentiate both sides with the base of 2. So I'll have b minus 3 is greater than or equal to 4, plus 3, and plus 3. And I have b is greater than or equal to 7. Okay, so there's the inequalities. Let's see, solve each equation. So these are exponential equations. Round to the nearest 10,000ths if needed. Okay, so let's go ahead and go for it. So first thing to do is to isolate the exponential expression. So that'd be this right here. So I'm going to first add 3 to both sides. So 9e to the n plus 6 equal to 27. Divide by 9 to isolate it. So I'll have e to the n plus 6 equal to 3. Alright, so now that I have the exponential expression isolated, I am going to take a logarithm of both sides. In this case, I want to use a natural log on both sides since my exponential is base e, and natural logs have a base of e. And then these would cancel, leaving me with n plus 6 equal to the natural log of 3. And then I'll subtract 6. I'll get n is equal to the natural log of 3 minus 6, which will be equal to, let's try it out here. So natural log of 3 minus 6, I get negative 4.901. I don't really care how many places you round. I'm not strict on rounding, so that's fine with me right there. Honestly, if you just want to round to the first decimal place, second decimal place, we'll say at the minimum 2 decimal places. If you want to go further than that, that's fine with me. Alright, so for this one right here, let's add 7. So I have 8e to the 5n equal to 47 plus 7 will be 54, I believe. Then I will divide by 8. So I have e to the 5n is equal to, let's see, 54 divided by 8 is equal to 6.75. Yeah, sure, let's go ahead and use decimal, 6.75, why not? And then I'll take a natural log again on both sides. So I'll have 5n is equal to the natural log of 6.75. And then I'll divide by 5. So I get n is equal to the natural log of 6.75 divided by 5. Let's try that out. So natural log of 6.75 and divide that by 5. I get a 0.382. Okay. For 40, let's see, here's my exponential expression. Let's first divide by 8. So I'll have 20 to the negative 3x equal to, 58 isn't divisible fully by 8, but let's see what decimal we get. 7.25. let me write in blue, sorry. So I'll get 20 negative 3 to the negative 3x is equal to 7.25. And now what I'm going to do is use a logarithm, but in this case I'll use a log base 20 on both sides. So I get negative 3x is equal to log base 20 of 7.25. Then I'll divide by negative 3. So I get x is equal to log base 20 of 7.25 divided by negative 3. Now, in order to use your calculator for this, you'll have to use the change of base formula. So log 7.25 divided by log of 20, was it? And then I'll divide that by, do we say 5? Nope, divided by negative 3. I get negative 0.220. There you go. For 41, so here's my exponential expression. So I'm going to divide by negative 9, divide by negative 9. So 12 raised to the 3p minus 1 equal to 37 divided by negative 9. I'm just going to leave it as 37 divided by negative 9. Alright, from there, I'm going to use a logarithm of base 12. So then I'll have 3p minus 1 equal to a logarithm base 12 of 37 divided by negative 9. I'm going to add 1. So I get 3p is equal to log base 12 of 37 divided by negative 9 plus 1. And then I'm going to divide by 3, divide by 3. So I get p is equal to log base 12 of 37 divided by negative 9 plus 1 divided by 3. Now this is kind of a tricky one to put into your calculator. If you honestly wanted to leave it like this, that's an exact answer, which I'm okay with. But let me go ahead and show you guys how I would do this in the calculator. Make sure you have it written down so you can follow along with me in the calculator. So let's see. So first of all, I have it written down here so that I can look at it and do the calculator. So starting with a logarithm, so I would do log of 37 divided by negative 9. So I have that. Second. Yeah, I actually think that, let me go back and look at this right here. This one would actually probably be no solution. So the reason why I say that, so because of the situation that we just had, so because we did logarithm, so 37 divided by negative 9 is a negative number, negative 4.1111. So what that means is that, logarithms, you can't use a negative number inside of a logarithmic expression. So honestly, we actually did way too much. I guess you could say this right here, but because of this, there's actually no solution. So keep that in mind. We went way too far, far than what we actually needed to go. But, oh well. For 42, so let's see, we have 5 to the v minus 2 equal to 18. Since this is already isolated, let's just go ahead and use a log base 5 on both sides. So then I'll have v minus 2 is equal to a log base 5 of 18. I'll add 2 and add 2. I'll get v is equal to a log base 5 of 18, close that, plus 2. So that's going to be log of 18 divided by log of 5, and then plus 2. So we'll round that up to just be 3.80. Alright, this one right here, so here's the exponential. Isolate it first, so minus 5. So 8 to the negative 7v is equal to 12. Use a log base 8 on both sides. So then I get negative 7v is equal to log base 8 of 12. Divide by negative 7, divide by negative 7. So I get v is equal to a log base 8 of 12 divided by negative 7. So log of 12 divided by log of 8 divided by negative 7, I believe it was. Yep, so I got negative 0.170. Okay, and I think that's everything. So quite the review. Should be plenty of practice for you guys to prep for the test. Let me know if you have any questions.